Good morning, guys, and welcome to my channel, Rosa Technocrat. I'm putting this video after a long time, and it because I got busy in different work, and I'm very sorry for that. So today we will talk about a link aggregate interface or the lag interface. We will be doing all the troubleshooting on the lag interface, understanding all about the lag interface, how the packet flows, how the link aggregate is established, what are the different methods to troubleshoot a lag interface. Let's start. Okay, so this is all what we are going to learn from this about lag interface, which is also called a link aggregate interface in Fortinet. What could be the potential causes for the lag interface going down? How to fix or identify any lag issues, different LACP issues or lag issues that you potentially can occur, and different LACP modes because link aggregate interface uses the LACP protocol for setting up the bundle. Okay. So when we are creating interfaces on the FortiGate, you might have observed different options under type. So if you see here, so when we go under interface here on the FortiGate menu, and if you go under type, you will see these are the different possible options under the type, which is 802.3 AD aggregate. That is what we are going to talk about, which is link aggregate interface or aggregate. In other vendor terminologies or like Cisco, we also call it as port channel. So for example, in Cisco, we call it as port channel. And yeah, overall port channel is a common name everyone knows because initially all networking started with Cisco. Yeah, so most of us knows by the name port channel. And now Fortigate call it as an aggregate or link aggregate interface. There are other different options as well, emac, VLAN, loopback interface, redundant interface. So that we will not be talking today, that we can have separate sessions for each different kind of interfaces. So let's start on the aggregate. When we are creating an interface, new interface, if you select the type as 802.3 AD aggregate, that creates an port channel interface on the FortiGate. There are three different modes for an aggregate to work properly, and we can decide any one of these methods depending on what the partner uses. The one of the method is active, second is passive, and third is static. You might have gone through all these different modes or you already know about all these modes, but still I will just give a quick refresher onto these. Active is basically where LACP negotiates between the partner and the local device, and they agree on a method. They say, yes, we both are ready to participate in this link aggregation. So let's go. That is called the active mode of LACP. Then we have passive. So passive is where one of the partner is like says, okay, I want to form a LACP, and you simply accepts those, and you simply listen or you are ready to participate, but you are not sending the LACP. That is called passive mode. In active, you are proactively continuously sending the LACP packets. In passive, we are not sending it. We are only listening. And the third one is the static. So where you simply say you have to be a link aggregate interface. No need of any negotiation. We statically say, yeah, you are part of a link aggregation interface. So that is static. So active, passive, and static. Three different modes of LACP. And LACP is the protocol which is used to set up the link aggregate interface. And depending on the remote device, you might have to adapt the LACP mode appropriately. So basically, just to show you, for example, this is our FortiGate device and this is the partner. Partner with the partner, we have got these two interfaces which needs to be in a link aggregate. So we generally represent these as like these round circles as a symbol for to represent an aggregate interface. So when we bundle any two interfaces or more than two interfaces together, it can be like three or four interface can also be bundled all together. So these interfaces which participates or which are member of one aggregate interface, these are called the interface members. So for example, port 1, port 2, port 3. So 1, 2, 3, these are all members of leg 1. This is just I'm giving you for an example. This is they are the member of leg 1. When we are talking about the modes, so either if it is active or passive or static, so it has to be similar configuration between both the partners. So this has to be similar between both the partners. So that's why we say depending on the remote device, you might have to adapt the LACP mode appropriately. So when you see on the Fortigate interface, if you go under network and select interface, you will be seeing this option aggregate. So under aggregate, you will be seeing all the aggregate that are created, any IP address that is assigned, and you can see the type here aggregate and under subsection aggregate. This will only be seen if you have an aggregate interface exist, and if it does not exist, then you can create new and create an aggregate interface. So aggregate the main use of aggregate interface is to increase the bandwidth and to enhance the redundancy, because let's say if you have one interface between the two devices, which is a 10G interface or 1G interface, so this is one of the devices and this is the partner. So now you have one interface connected to them, that might be a 1G interface, but you want to increase the bandwidth or the capacity between the two switches. So then you add one more link to this, make them in a bundle. So now your capacity has been increased to 2G between the switch. So that is the main purpose or main use. Also, it provides redundancy in terms of even if one of these link goes down, all the traffic will still work on the one member. And if both are up, then your combined capacity gets increased to 2G or depending on whatever the link capacity you have. What are the conditions like when a interface can be a member of uh, link aggregate interface? So I will not go through all this, but to simply say, like only a physical interface can be a member of leg, not a VLAN interface, and it one interface member cannot be part of multiple legs. So it should be a physical interface, not already a part of an aggregate interface, and should be in the same VDOM if your firewall is having VDOMs. And all this means it should not have any configuration on it already referenced it, because if it is already being referenced by any other configuration, any firewall, any DHCP, any other configuration, if it is being referenced, then you will not be able to call it under the member interface, or you will not be able to add it because it will not be visible under the member interface list. And so of course if it is not visible you cannot bind it, right? So major points, the main points here are these three ones, like it should be a physical, not a VLAN, not part of existing one, and these all points are related to like it should not have an already defined configuration on it. Now this is little advanced point. This I will talk when I will be doing the practical or after a few slides. So this is because when we create an aggregate interface, it's always the primary or the master firewall that participates in the LACP negotiation. And if you want the leg to be established even from the slave at the same time, so then we have to use this command if it is an HA, LACP HA slave enable. So what it does, it allows slave Fortigate also to participate in the LACP negotiation. Otherwise, what happens when the master goes down and the slave takes over, that time only it starts to negotiate the LACP. But if you enable this command LACP HA enable, so this is something important for those who are having an HA setup. And yes, I recommend to have this as enabled so that at any point of time your both the firewalls in cluster will have the lag interface up and negotiated. Otherwise, during any failover, the negotiation will start take place, and it might take some time for, or in any for sorry, in case of any issues later on that might delay your failovers. So I recommend to have this LACP slave enabled on in the configuration so that even the slave firewall can participate in the LACP negotiations. Okay, so now this is an example of a LACP interface configuration which we can do. So what we does is we have to go under config system interface and edit LACP port. So edit LACP port is any name that you give. It can be LAG1, inside lag, or any custom name that you want to define. And then we have this interface is part of which VDOM. Uh, this is that tells this interface is of type aggregate and which ports are going to participate or the member of this interface. So that is set member port 1. And this description we just give it for our reference. These are the default commands on an LACP interface which can be changed or customized, means based on our configuration. So by default, the LACP mode on the firewall is active if you don't change it. And as I was telling, LACP HA slave enable. So this is also by default enable, and I recommend you not to disable it so that slave can also participate. Then the LACP speed is slow and algorithm is L4. I will explain you about this algorithm and LACP speed also. But let's continue this later on during the lab. I will explain what all these different speed and algorithm and slave means. Okay, let's go. So this, when you are troubleshooting, let's say you have already created an aggregate interface and now you started troubleshooting. So for now, what we have done is we have just created an interface, lag interface, and not defined any members under it. And then if you run, this is important command, you should make a note of it, which helps you like in all the troubleshooting for any aggregate interface. So this is diag netlink aggregate and the name, and here it will be the name of the aggregate interface. Diag netlink aggregate name and the name of the interface. So when there is no member under the aggregate interface, you will see the status here as down and no members are showing under it. So because for now there are no members here, so only this is the configuration it is shown here. You can see here the configuration which we were talking about default, it shows here LACP mode active, LACP speed slow, LACP HA enable, and the algorithm. So you can use this command to verify all the configuration on the lag, and also any issues, uh, any status issues, any speed configuration match, this can be verified from this. Not only this, when we go ahead, we'll see more use of it, and it's actually the main and the important command to see any issues with the with the lag. Let's go. Now I added up some members and my LACP interface is up or the lag interface is up. So when you see here, this using the same command, diag link aggregate name and your aggregate link. So you can see the status of the lag is up. Okay. The algorithm that is being used is L4. Okay, let's talk about the algorithm here. What is this algorithm? When you have multiple interfaces as part of the lag, It's the algorithm that decides how the traffic will be distributed between both the ports. So this algorithm can be L2, L3, L4. L2 is just based on layer 2, that is MAC address level. So based on MAC addresses, the hash of the MAC address, it will be sent to one of the interface. And the same source and destination MAC will always land up ending onto the same interface. Same way, L3 considers the IP address of the source and destination and uses the hash to send them to one of the member interface. And again, ending up on the same interface. If you are continuously sending heavy traffic from same source and destination, then it will also end up only being utilized on one of the interface. And L4 is the mechanism where it uses source IP, destination IP, and source port, destination port. Because it works on layer 4, it can take ports into consideration. So layer 4 is the default method. So this is all about distribution algorithm. We can talk more about later on. If you need more details onto this, I can make one more video on this. And then LACP mode, we saw LACP speed, LACP HA enable. This is the aggregate ID, that is the ID for given for the lag interface. Ports 2 means how many interfaces are member of this leg, count of. So if you have two interface or three interface, so it will show you the count of the interfaces that are part of this. Now during the troubleshooting, these are the important parameters like actor MAC address and the partner MAC address. So actor is basically the Fortigate itself MAC address, self MAC address, okay, and partner is the remote device or switch MAC address, remote, okay. Then we have got the status. Link failure count is how many times this interface has been failed. And the most important is these states. If there is a mismatch in the partner states, then your lag will be down. So whenever you are troubleshooting, you always check the actor state and partner state if they are matching. This is most important for any lag configuration. And what are these states or the flags? So basically all these values ASAIEE, they represents one of the flag. And what does this mean is, if you go here, you can see this is explained here. So A is means LACP mode is active, and if it is active on both the sides, it will show here AA in both states. Okay. Then if you see S, that is the LACP speed. So you saw here slow. So in actor and partner, it should be same. If both are A, then it should be both A on both, and either S LACP speed. If it is slow, then it should be slow on both. So while troubleshooting, you should notice these two partner states. This is very important to understand where might be the issue between the legs. So same way now here it was showing for port number 7. Okay, this is one of and the other port. I have the other port as slave port 8, which is also up, and there also the state is ASAI. So so both the interfaces are now part of the leg, and you can see everything here. So the important command to troubleshoot a lag interface is diag netlink aggregate. Okay, let's continue. So the same command which I explained earlier here. So you can see the first one is diag netlink aggregate name and the name of the aggregate interface. Second is diag netlink aggregate list. So list basically lists all the available lag interfaces on the firewall. Then we have got diagnose hardware device info, NIC, and then the port number. So this is to check any issues with respect to individual interface or the member interface. So using this command, you can know any CRC status and then speed, duplex. All this can be checked by using diagnose hardware device info, NIC port, and then the port number. And the last is the diagnose sniffer packet, any ether proto. So this is basically to capture the LACP negotiations between local and the remote device. So I am filtering the protocol 0x8809 to filter only the LACP messages. So this protocol number 8809 is specifically for this means LACP messages. This means LACP messages. Okay. So these are the four commands which you need to use for any troubleshooting on the lag. Okay. Let's continue. So this, let's say when I was doing diag link and I saw the partner states are mismatching and my remote device or the remote admin or the network engineer is saying like there is no issue from the switch side, everything is fine, you have to check the firewall, we don't care, or all good on the switch side. They promise it's all good, you have to check your firewall. In such cases, we need to take the packet capture to prove or to verify for us also, like whose mistake it is or who is sending what. Okay. So on the 40 if you do diag sniffer packet, so this is basically a TCP dump kind of, everyone knows. If you are working on Fortigate, you should know diag sniffer. I'm not going to explain it. Sorry. Okay, so diag sniffer packet, and I'm just filtering out the LACP message here using 8809. And when I capture the packet, okay, let me tell you about 60A. So this 60A, 6 is the level, verbose level, and A is the timestamp, whether it's absolute. So A means it's UTC time, standard time. And if you use L, then it will take the local time from the firewall. So when we are doing diag sniffer, you can see the LACP messages coming on port and coming out going, not coming, I'm sorry. So coming in and going out on the port. And when the LACP message is received on port 2, you can see in the header or in the YSR capture the state that the partner is sending, ASODD. And if you see here on port 2 out, what we are sending is AIDD. Okay, so that means there is a difference in the flags. So that means that clearly points out like there is some configuration mismatch between both the devices. So by using a Wireshark, we can prove who is sending what flags, and in and out we can confirm where is the problem and why the LSAP is not being negotiated properly. When I took an look, or I converted the SAM diag sniffer data into a Wireshark, you can see here all the analysis like actor states. So actor state, LACP activity, LACP timeout, synchronization. So these are those different flags. And same way you will see here the partner state. Partner state is from the remote end. So if you expand that particular packet, LACP packet, and go under link aggregation channel protocol, you will be able to see these details here. I already explained about these commands like diagonal sniffer, which shows you the packet header for LACP messages, and this you can just use to filter 8809 only for LACP messages, and these are the four different commands that I have already explained in earlier slides. So this I have just drawn a flow chart, like if you are facing issues with the LACP, what you should do. Either it can be either full member, all the members of the leg are down, or one member of the leg is down, or leg is not going down even if the interface on the remote is down. So in case all members, it's 100% check configuration because leg is not at all coming out, and 99% of the time it's because of the config issues. And you can also verify LACP mode and configuration parameters as I had shown, and take packet captures. In case of one member interface is down, that means it's probably because of layer 1 issues, maybe cable issues, CRC issues, or any SAP issues. So you should verify these things. And in such case, it's the L2 device issue, and enabling, disabling, or bouncing the ports might help if it is like not going down. Okay. I have used all these references in my video, and let's jump on to our practicals into the lab, the most interesting. Let's go. Okay, so now I'm here with my device. Let's go and start. This is my device. I'm doing a diag, net, link, aggregate, name, no name. First, let me list. I will list. I can see there is one aggregate which already exists. Let me increase the size of the font size so that it becomes little big. Yeah, now it's better because earlier it was very small. Okay, so if I'm doing diag net link, aggregate and list, it shows it will list all the lag interfaces. Currently, I have one aggregate which is in status down algorithm. Let's use the command why it's down. Diag net link aggregate and the name is Fortilink aggregate name Fortilink. We can see here, as I told, like it's not showing any members because I don't have any port configured for it. It is just a leg. So you can see here the status is down and LACP mode active, speed slow, H enable, but there are no members. So if there are no members, then enjoy. Because of no members, it's down. If you want me to configure a lag and then see, let's go ahead. I will do it from the CLI itself, config system interface, edit. I will give the name test lag and I will add members, set member. What is the command? Set. Sorry for this. Oopsie. I already told you the command. Yeah, so set mem. Why it's not coming set members? Oh, yes. First, we have to see set type as aggregate. Once we do set type aggregate, then it will start giving the command set member. And which ports are going to be my member? I will just verify. Let me verify it. And okay, so I have port 5 and port 6 as the member, and oh, VDOM must be set. So now we have to do config system interface, edit test lag, and then set type as aggregate, set member as port 5 and port 6, set VDOM as root, and then end. Okay. Now if we do diag net link aggregate list, you can see two lag interfaces and still we see my test lag is down. Let's see why it is down. First, let's verify the member diag net link aggregate uh, aggregate name and it's test underscore lag. Okay, here we have the port 5 and port 6 as the member, but they are down. The interfaces itself are down. So let me enable the interface. Config system interface, edit port 5, set status, enable. Set status up and config system interface, edit ports 6 set status up, and let us see now our diagnet link interface diagnet link aggregate, sorry, aggregate name test underscore link. Oopsie, it's not test underscore link, it's test underscore leg. Okay, so now also we see the status is down, probably because it's down from the switch side also. Let me make it up on the switch as well. Okay, so once I made this port up from both switch side and Fortigate side, if we run the command again, diag link, you can see member port 5 is up, member 6 is up, and the states are ASA, PSA, because we are active and he's passive, but it works. That means he will still participate. So he will still participate with us. Okay, here also it's ASAIEE and PSAIEE. So A is for active, P is for passive mode. So passive mode can work in the link aggregation because he will accept the LCP message and will participate. The only difference will be he is not going to send the LACP messages. So hope you enjoyed. Okay, let me show you the capture also. One moment. When we are taking the captures for the LACP messages, we can simply use this command to filter all the LACP message that is being sent. Let's start. Okay, so let's see what LACP messages are being sent. You can see here our FortiGate firewall is sending LACP PDU on port 6 out, and this is our partner state. You might have noticed something. If not, let me tell you. Uh, you only see here out messages, right? Out messages, correct? Why? Okay, so here you can see LACP messages are getting exchanged between them, and it's all good. So this is how you can capture the packets for LACP by just filtering using 880x889. So this is a command to use to filter LACP messages. Hope you enjoyed my video and you will use this in your troubleshooting, and I might be able to help you, and this video might help you to fix your lag interfaces issue. And please do let me know for any comments or anything that I can support you with. Thank you so much, everyone, and please do like, subscribe my channel as everyone says. Thank you. Goodbye. Bye bye.